So our next speaker today is Naomi Carson from the Fraser Valley region.
For some people, a visit to the Vancouver Aquarium is a twofold adventure. Firstly, of course, they come to admire the beautiful aquatic creatures, many of whom are native to our own West Coast. But for the nosy ones, there's something else to look at. Something behind the scenes, but of the utmost importance: filtration. Good morning, ladies and gentlemen, honorable judges, master of ceremonies, leaders, parents, and fellow 4-H members. I might be the only person who goes to the aquarium and wonders about the filtration systems. It's a side effect of one of my hobbies. I am something of a fish farmer. Okay, not so much a farmer as a fish keeper. I have several aquariums with creatures ranging from small tropical fish to freshwater shrimp to aquatic salamanders. But what does any of this have to do with fish farming, you may be wondering? Surprisingly, a lot. Advances in fish farming techniques and the use of technology are remarkably similar to what freshwater aquariums hobbyists are using today on a much smaller scale. Firstly, let's take a look at how the vast majority of salmon are being farmed in BC, since salmon is one of British Columbia's top 5 exports. As you may recall from science class in elementary school, the salmon life cycle begins as an egg, which hatches into a tiny baby fish called a fry. These fry grow up in freshwater streams. After a few months, they are called smolts. These smolts travel to the ocean and there mature into full-grown salmon. Farmed salmon are kept in freshwater ponds until they reach the smolt stage. At this point, they are transported to open net farms in the ocean. These farms are pens that allow local seawater to flow directly through to the fish. As you can imagine, this has a huge impact on the environment. Pests such as sea lice are free to travel between the netting to affect wild salmon populations. Any chemicals used to treat the farmed fish are flushed directly into the ocean, as well as the waste produced by the fish. Any salmon that escape can compete with the wild population for food. Open nets also expose farm salmon to environmental hazards, such as strong currents, pollution, and aerial predators. All of these stressors affect the size and growth rate of farmed salmon. Farmers and scientists alike are looking at ways to improve farming techniques to reduce the effect it has on our oceans, as well as to improve the health of our farmed fish. One option being worked on is to keep the adult salmon in fully enclosed on-land ponds, a saltwater version of what the fry are raised in. This will ensure that waste can be properly disposed of and prevent the cross-contamination of disease from farmed to wild salmon. Of course, this system of farming is not going to be as simple as just plopping the fish into some pools. If left in an enclosed space with no means of filtration, toxins can quickly build up in the water and kill the fish. And that is where my aquarium comes in. Like any enclosed fish farm, my aquarium has a filter with many components. The first is mechanical filtration. This is a sponge which catches large particles of fish waste and uneaten food as the water passes through it. I rinse this sponge every so often and use the water to fertilize my houseplants. Waste from farmed fish could likewise be used in fertilizers. The second is biological filtration. This is made up of small pebbles or plastic spheres with a large surface area. Lava rock works very well for this, as its surface is covered in small holes. Fish produce ammonia through their respiration, as well as through their waste breaking down. Ammonia is very toxic and can quickly build up. Biofiltration allows a place for beneficial bacteria to grow, which eat the ammonia and convert it into nitrite. Unfortunately, nitrite is still toxic. So there's another type of bacteria that will eat the nitrite and convert it into nitrates. This is much safer for the fish. The circulation of water through the filtration system also replenishes the water's oxygen supply. This can be supplemented with air pumps, which agitate the surface of the water to allow for better gas exchange. Finally, fish farms can use UV sterilizers to remove any remaining organics, such as free-floating algae. The filtered water is then pumped back into the ponds to be circulated again. Fully enclosed systems such as these recycle 99% of the water from their initial setup, with approximately 1% being lost to evaporation. Research continues to be done on how to improve on-land fish farming systems, mostly to reduce the cost of setup. But the day might not be far away when farmed salmon no longer affects our local waters, when wastewater can be used to fertilize crops and farmers lose less salmon to disease and escape. The simple home aquarium may change the fish farming industry forever.